Okay, so I think let's get started. Thanks everyone for attending these sessions. My name is Patrick Lai. I'm from Qualcomm audio software team. Today I'm here to go over the AudioReach open source project. If you have attended the keynote today, our SVP Linders kind of brought up this point that Qualcomm historically has been not, very accustomed to open source, and so this is actually going to be the first open source project that we have ever done. So I'd like to ask, the community's patience, and so that this is going to be a journey that we would like the community to be participating and providing guidance. Okay. So yay, Qualcomm is going to open source AudioReach. But so what is AudioReach, right? Let me give you a quick introduction. So AudioReach is the audio software solution that Qualcomm developing in-house. It's a complete end-to-end solution that with software components span across the embedded device as well as the host PCs. And these are some of the highlights. AudioReach enables the off-target use case development. So the developer who wants to build an audio product, they can start their whole development starting from host PC itself. Then the next highlight is the graphical design and configuration interface. That the use case designer, algorithm designer will be able to use the GUI-based tools to design their product. Then once they're done with the designing, there is all suite of test suite for testing and simulations. And once you're done with the off-target or on the host PC development, there's an easy path of deploying onto the targets, doing the integration, test, and tuning, for that particular form factors that the developer is developing on. AudioReach has already been commercialized on a wide range of Qualcomm products, starting from wearable, autos, handset, XRs, as well as compute. So it's it's well tested for different kind of applications. Okay, so regarding this open source project, I'd like to highlight 3 messages to the communities. Starting from the top, in terms of hardware support, we don't want this project just to support Qualcomm hardware itself. As a matter of fact, we want to reach out to a wider community, through enabling the AudioReach on Raspberry Pi. And later on, we'd like to enable non-Qualcomm hardware with, Extensa DSP, Extensa Hi-Fi DSP on the particular SoCs. Just to know that actually recently, we just past 2 days, we actually got AudioReach running on Raspberry Pi. I'm hoping to set this up in tomorrow's demos. So yeah, so this is a great testament that we don't just want to support AudioReach on Qualcomm hardware. Next point is the license setup for this open source project would be primarily BSD3 license. So it's a more permissive license that when the algorithm solution vendor have their algorithm IP running through AudioReach, they are not required to have their secret sauce open source. And in terms of governance model, we want this project to be eventually grow to a community-based project. So, we'll welcome the contributions, and also we liked, participant. Welcome to start the steering committees, so that we can collaboratively, build up these projects. Okay, so why do we think AudioReach as an open source project would benefit the ecosystem? We believe because of these 4 main points, starting from leverage standard ecosystem APIs. What this means is that we don't want, what we are trying to do is we want to establish interoperability with the ecosystem software and tools so that the application that's developed on top of, for example, GStreamer, Pulse Audio, those applications don't need to change its API in order to interoperate with AudioReach. And as I mentioned, that the developer will be able to start its own development starting from the host PC and later on deploy onto the target. AudioReach is written to be highly cross-platform portable. As a matter of fact, as I mentioned, we already have AudioReach running on multiple different product lines of Qualcomm portfolio. Some of them actually run, like, for example, Windows. Some of them actually run the RTOS. So AudioReach is, it's been tested, it's highly portable. Then the last point is quite scalable for, hardware platform with different capabilities, starting from very high performance, mainly for auto type of use case, down to wearable, where it's more memory constrained and computation constraint. These are things that it's, as I mentioned, AudioReach already been running on those products. It's proven to be quite scalable. And with all these points, we believe that AudioReach open source project would help lower the development and maintenance costs for the ecosystem developers, covering the application developers, algorithm solution developers, even the OEMs, ODMs, silicon vendors who can take AudioReach and port it onto their hardware platforms. Okay, so what is AudioReach SDK composed of, and what are the highlights? I just want to mention that we don't have every pieces built to date. Some of them are actually on our roadmap, and as part of the overall visions. So the ones that's kind of surrounded by dotted, block are something that we haven't yet built, and this is something that maybe even community developer can help us build up these blocks. Okay. So first is the one of the key component is AudioReach Creator. Today, if you want to download AudioReach Creator, it's actually called Qualcomm Audio Calibration tool today. But this is something that eventually I would like to rename it to be more neutral name than having Qualcomm as part of that names. So this is the main tool that allowed developer, which provide the GUI environment for the developer to design and configure the audio use cases. Through these tools, you'll be able to import, the processing module that the designer is designing, and able to, form the audio use case graph by drag and drop those modules available for your systems. And then on the embedded side, we have a signal processing framework acronym SBF, deployed on the main audio DSPs. We also have SBF also deployed on the offloaded DSP. We even have SBF even deployed on the ARM side. So it's a signal processing framework, able to support, as I mentioned, wide variety of product use cases. It's highly flexible in terms of allowing plug and play. You can easily drop in, the algorithm modules. It supports dynamic loading, so you don't really have to build all your use case, modules into the DSP image by itself. It's highly portable. It has a clean separation of a generic framework as well as the portion of the framework and a layer, what we call pulsar platform OS abstraction layers. Then one thing I want to highlight is the way we envision, how we want to be a key capability of these solutions, allowing distributed processing across different processors. So in the ARCs, you'll be able to kind of partition your use case graph, part of the graph to run, on the main DSPs as well as offloaded DSP. And if you have some algorithm that's optimized for ARM, then you can actually offload it back into the SBF running on ARM. And all these are kind of hide underneath that, it's all transparent to the applications. Then we have this something called ACDB, Audio Calibration Database. This is where all the use case topology graph and graph definitions are stored, as well as the tuning data for your use case are all stored here. Then we have this cross-OS graph service platform. Essentially is the control software that's interacting with various SBF or signal processing framework running on different subsystems. This is the one that will be providing the API to the client to set up a use case graph and interacting with the use case graph running on this SBFs, various SBFs. And this is the one that will be query the ACDB to download the graph definition as well as the device tuning data. As I mentioned, we want to make sure that the ecosystem API are still be supported. So we actually developed the plugins such as ALSA plugin, Pulse Audio plugins, later on Pipewire plugin to interact with these audio frameworks, the established ecosystem framework. And coming back to the ARC AudioReach creator, not only that the developer will be able to design the use case and configure audio use case, through these tools. ARC also support runtime audio graph modification. So, when a designer is designing their use case graph, they can run it first, right, and realize there's a missing module that he or she wants to insert into the use case graph. The designer will be able to run time while the use case is running and able to insert a new modules or delete the module all at runtime without stopping the use case. And then it also support module tuning, real-time tuning. So as the use case is running, you can pick and poke the modules to change the coefficients at runtimes without stopping the use case. Then it also support processor resource monitorings. A lot of times, like if you're running too much of processing on the DSP, might run out the MIPS. So through this resource monitoring, real-time resource monitor functionality, the use case designer can figure out, okay, if I'm running use case, run out the MIPS, maybe I want to offload it to another DSPs or offload it back to ARM. All these are supported using these ARC tools. Okay. So this is something we recently enabled. This is, we have all the pieces that's running on the embedded system running here in the off-target simulation mode, so that use case designer developers can use this platform to run their simulation first. Then, some of the things, pieces that we would like to build in the future is integrated IDE allow you to do coding, debugging, and profiling all through the IDE. And we also want to, build up this interoperability with industrial standard algo design tools such as MATLAB, Simulink, to be able to allow, developers who's used to developing their algo in the standard industrial tools easily deploy onto AudioReach framework. Then eventually, even though we have the simulation support today, we don't have the, like for example, if application wants to run written on top of pulse audio pipe wire, today we don't have the support to allow the application running in the simulation mode. This is something that eventually we'd like to build to support this kind of end-to-end testing, so that even the application developer can benefit by running their application in the off-target environment. Okay. Then in terms of this is more a vision today. This is the development workflow that we want to enable through this open source project. And this whole workflow, we are kind of looking at this at the currently is in the infancies. So don't read too much into the exact steps. But what we envision is, the algorithm, the use case designers will start the development off target using the standard industrial tools, like for example, MATLAB, Simulinks. Then once they're done with the initial development, we can easily take some of the customizations and data files, import it into the ARCs. Then start using the GUI environment to design and configure the system use case. And we even envision that once that use case is designed, we can actually use the off-target simulation platforms and to run the use case. Then the audio data can actually pipe back into, like for example, MATLAB, go through the processing in the lab, MATLAB, and pipe it back into the off-target simulations. And once the validation in the off-target environment is done, we envision that we can even deploy the testing from MATLAB into the actual target, and so that you can actually validate your algo running on the particular hardware platform agnostically from AudioReach. And then once all the testing is done, then we envision that we can have the tools, generate the compile and auto-generate the algorithm optimized for particular DSP architectures, then wrap around the AudioReach module interface so that it can easily integrate it into the use case graph. And once that's done, then we'd like to be able to seamlessly export various configurations for various software stack running on the SoC itself. And then, once it's deployed, the developer will be able to integrate, test, and configure and tune on target. Actually, I forgot. I didn't know that this was animation. Apologize for this. So just want to highlight the cutter scheme. So the steps that's pretty much done on the host PC simulation environment are highlighted in these cutters. And for the steps that are running on the target are the step 7 and 8 in these cutters. And this arrow talks about the roadmap. Today we're able to export, for example, ACDBs, configuration files for the graph services and SPF, through the UIs, but we haven't integrated to export configuration files for, the plugin that we wrote for, like, for example, ALSAs. And if we want to configure, for example, Pulse Audio to run with AudioReach, there are some config files. These are things that is on roadmap. But the goal is to enable the whole development workflow all through the tool itself. Oh, okay. Yeah, so very quickly, this is the, as I mentioned, we already ported onto many platforms. But AudioReach, this is the overall AudioReach architecture on Linux. We have 3 different paths. One path is directly going to the ALSA kernel. Today we already have the driver upstreamed. Currently is it only support basic renderings and captures. If you really are looking for the full feature sets, then I will recommend that you use one of the user mode architecture path. This one is, we have Pulse Audio directly connect to or run on top of libALSA, and then we have ALSA plugin to interact with the generic AudioReach components. But we also have this path which interact with this PAL layer, platform adaptation layers, which is the middleware-like layer that provide the turnkey solutions or logic to manage wide variety of use case and sound devices. So as a Linux developer, you will have 3 paths that you can enable AudioReach with. And then I'm going to quickly go through the slides. Essentially, we have already developed Yocto meta layers for AudioReach. So ideally, a developer will be able to, purchase if they want to deploy AudioReach, they'll be able to, acquire the hardware supported by the projects. By having this meta layer, everything will be pulled just from the open source projects, and build your image. Then you'll be able to download AudioReach creators today from Qualcomm Developer Network and start your use case design, and then deploy onto the boards and tune your devices with ARCs. And once everything is done, and then you deploy. Okay, so this is the roadmap we have. Actually, today we already have AudioReach open source project created. We're in the process of populating the source code and the documentations. And then for the phase 2, we're aligning to Qualcomm Linux initiative. We want to enable AudioReach on the RB3 Gen 2 platforms. We actually enable on the RB5 Gen 1, but as part of this initiative, we'd like to align to that. That's why we are looking at June launch to support Qualcomm reference platforms. And for phase 3, we want to enable Raspberry Pi, but as I mentioned that we already got something going like the past couple of days. So we should be able to demo this in tomorrow's demo day. Then phase 4, we want to enable non-Qualcomm platforms with Hi-Fi DSP running Zephyrs. Then later on, we have phase 5, 6, 7. Part of it is, we recognize, the developers community would like to have the AudioReach creator open source. So this is something that we'll definitely be considering and working on. And yeah, I mean, anyone is interested in this project, feel free. That we'll, this is not set in stones. We'd like the community, chime in and help define the roadmap. Okay, that's end of it. We'd like to look for participation, collaborations. The project URL is github.com/AudioReach. We have a demo set up tomorrow. Come to check out AudioReach in actions. And lastly, we have a 1-minute demo video to get everyone excited about this open source project. So let's go through it. And this is the real-time monitors that you can actually know how much each module is able to utilize the DSP's computation power. And a lot of times you want to know how much of latency the modules are introduced into the path. So we're able to log the data in different tap points and do a correlation comparison to figure out how much latency is introducing. All right. That's the end of it. Thanks for listening to this presentations. Yeah. Feel free.